This is illustration of driller method to remove the influx from the bottom of the well, bring it to surface and evacuate the influx out of the wellbore using two steps of circulation. And this is the first circulation explanation. Basically, we will pumping old mud inside the wellbore through the drill string and then push the influx out of the well, and we will continue to circulate until no more influx left in the annulus. Initial condition: pump is off and choke is closed. Drill pipe pressure gauge here will showing us shut-in drill pipe pressure, and our casing pressure gauge here showing us shut-in casing pressure. At this time, the influx still at the bottom of the annulus, most probably around the BHA. Our drill pipe full of mud from the surface all the way to the bed. We will start circulating slowly, pumping and opening the choke. We will start increasing the pump speed gradually, and at the same time we will open the choke gradually. We will maintain casing pressure constant. Now starting the pump up gradually from 0 to 5 and open the choke to 11%. Now from 10 to 15, open the choke to 25%. Now from 25 to 30 and open the choke to 48%. We can see that during this process, we increase the pump speed gradually and opening the choke gradually, and we maintain casing pressure constant. While we are pumping, the influx will move up in the annulus. We pump at constant pump speed 30 SPM. We can see that casing pressure will increase and pit gain will increase, but the drill pipe pressure remain constant, and we don't need to adjust the choke very often. During this process, the main thing is to maintain drill pipe pressure constant at the constant pump speed. Adjust our choke only to maintain drill pipe pressure constant. Casing pressure will increase and pit gain also it will increase because the gas that moving up in the annulus is also expanding. Now the gas will start to come in out through the choke. So we need to reduce the choke opening. Here we reduce from 48 to 34%. And we see the pit gain is decreasing because the gas had been evacuated out of the wellbore. We see that during this process, we maintain drill pipe pressure constant. When the mud is still coming out of the choke, we open the choke to 48 and we see that casing pressure will be maximum, pit gain will be maximum when the gas is just below the choke, and when the gas start to coming out of the choke, we reduce the choke opening from 48 to 34% to maintain drill pipe pressure constant 880 psi. We will monitor pit gain decreasing as more and more gas moving out of the annulus, and then when all of the gas is out of the wellbore, the mud will come back to the choke, and we need to reopen again the choke from 34 to 48% to maintain drill pipe pressure constant. After removing all the gas out of the annulus, casing pressure has been decreased from 755 psi to 600 psi, and also pit gain will be decreased from 16 barrel to 0 barrel. Now we will slowly shut down the pump and shut in the well. We decrease the SPM and at the same time closing the choke gradually. We see that during this process we maintain casing pressure constant. Now we will start the second circulation. Kill mud will be pumped at a constant SPM and we will circulate until mud width in equal to mud width out. At this condition, the well is still under balance, but there is no more gas in the annulus. To start the circulation, we will gradually increase the SPM and gradually open the choke. We maintain casing pressure constant. After the pump running to 30 SPM and displacing the surface line with kill mud, we will zeroing the stroke counter exactly when the kill mud entering the drill string. So we see here the kill mud start entering the drill string and we see the drill pipe pressure will decrease while casing pressure remains constant. More kill mud entering the drill string, the drill pipe pressure will decrease further. So we will have less and less drill pipe pressure. By the time all of the drill string has been full with kill mud, we will reach what we call FCP, final circulating pressure. At the beginning, we had 880 psi. We call this ICP, initial circulating pressure. And when the kill mud arrives at the pit, we have what we call FCP, final circulating pressure. During this process, we've seen together that drill pipe pressure decreases while casing pressure constant. At the same time, we don't need to adjust the choke too much. Now, the kill mud will start entering the annulus, moving up from the pit up to the open hole and then up to the case hole all the way to the choke. We see that during this process, our drill pipe is already full with kill mud and it is homogeneous. That's why drill pipe pressure constant while pumping the kill mud at the same SPM. So drill pipe pressure constant equal to FCP, while casing pressure will decrease from 600 all the way to 0, and we need to maintain the drill pipe pressure constant. So in case the drill pipe pressure increasing, we will open the choke. Once the kill mud is out from the choke, we will check with the mud balance. Mud width out must be the same with mud width in, and then we can shut in the well. If there is no trap pressure in the well, we will have shut in casing pressure equal to 0 and shut in drill pipe pressure equal to 0. Then we can perform a flow check through the choke, make sure the well is not flowing, and then with the choke still open, we open the BOP. Now the well has been killed. This kill graph here summarizing our process. At the beginning, when we circulate with old mud, we see that we maintain drill pipe pressure constant during the period. until all of the influx out of the annulus. We see on the casing pressure side, the pressure of the casing will increase gradually and reaching maximum when the influx just start to go out from the choke. The casing pressure then will decrease, and when all of the influx has been evacuated out of the annulus and the mud coming out from the choke again, then we need to adjust the choke, reopen the choke to 48% again, maintaining drill pipe pressure constant. At this point, no more influx is expected in the annulus. We can circulate for a while to make sure that no more influx is left in the annulus, and when we were sure that no more influx is left in the annulus, we can gradually shut in the well, decreasing the pump speed, maintaining casing pressure constant. And then we will start pumping the kill mud. When we start pumping the kill mud, initially the pressure will be the same with our ICP, initial circulating pressure, 880 psi. After the kill mud entering the drill string, the drill pipe pressure will decrease by itself. It will go down slowly, but we can see during this time we maintain casing pressure constant. When the kill mud reaching the bed, then our drill pipe will be full of kill mud, and therefore it is homogeneous, and now drill pipe pressure can be maintained constant. The annulus will decrease because we will have more and more kill mud in the annulus. At the end, the kill mud will come out on the choke, and we will see that casing pressure equal to 0.